what are called real numbers. A real number is nothing but a union of rational and irrational numbers. If we join rational and irrational numbers together, then they are called real numbers. Means the union of rational numbers and irrational numbers together are called real numbers. Real number is nothing but the union of rational numbers and irrational numbers. Q union Q dash is set of real numbers, or Q union S is set of real numbers. S is used to represent irrational numbers. Q dash is also used to represent irrational numbers, whereas this Q is used to represent rational numbers. Therefore, the union of both rational and irrational numbers is called set of real numbers. If you observe this diagram, you can find here is the first circle. This is set of natural numbers. Natural numbers may start from 1, 2, 3 and so on. And this is set of whole numbers. The set of whole numbers may start from 0, 1, 2, 3 and so on. Therefore, every natural number is a whole number. The circle N is included or inside the circle W. Therefore, every natural number is a whole number. Now this is the set of integers. Set of integers may start from minus infinity and end with plus infinity. Therefore, every natural number is an integer and every whole number is an integer. And besides whole numbers, there are negative numbers also in integers. Therefore, both natural numbers and whole numbers are inside the set of integers. And this is the set of rational numbers, which are in the form of p by q and q not equal to 0, and both p and q are integers. This is set of rational numbers. Every natural number is also a rational number, every whole number is also a rational number, and every integer is also a rational number. You see, the circle N and the circle W and the circle Z are the parts of the total circle Q. Therefore, all these numbers are included in set of rational numbers. The different circle represent the set of irrational numbers. Therefore, the numbers which are not rational are called irrational numbers. These irrational numbers are represented by Q dash or S. Now, if you include the set of rational numbers and the set of irrational numbers together, if you sum up all these rational and irrational numbers, you will get set of real numbers. Now, you see here it is the fundamental theorem of arithmetic. Let us see its statement. The fundamental theorem of arithmetic states that every composite number can be expressed as a product of prime factors in a unique way. I shall repeat, every composite number can be expressed as a product of prime factors in a unique way. Means in only one single way. Unique means in only one way. You may try to understand. First of all, what is a composite number? Composite numbers means a number which is having more than two factors is called composite number. A number with exactly two factors is called prime number, and a number which is having more than two factors is called composite number. Now, every composite number can be expressed as product of prime factors in only one way. Now, let us try to understand this statement with a given example. Now, if you look at this example, 30, you can write 30 as 2 into 3 into 5. 2, 3, 6, 6, 5 is 30. You see, you can write 30 as the product of three prime numbers. 2 is a prime number, 3 is a prime number, and 5 is a prime number. You can write 30 only in this way, and you cannot write 30 in any other way as the product of prime numbers only. Of course, you can write 30 as 6 into 5, but 6 is not a prime number. Therefore, you can write 30 as the product of prime numbers in only one way, and there is no other way. Similarly, look at 36. You can write 36 as 4 into 9. This 4 is 2 into 2, and this 9 is 3 into 3. 2 into 2 is 2 square, and 3 into 3 is 3 square. Therefore, you can write 36 as 2 square into 3 square. You can write 36 as the product of prime numbers in only one way. Similarly, 60. 60 is nothing but 4 times of 15. 4 is 2 square and 15 is 3 into 5. Therefore, 60 can be written as 2 square into 3 into 5. This is the only one way in which 60 can be written as the product of prime numbers. This is called fundamental theorem of arithmetic. Every composite number can be expressed as the product of prime factors in a unique way. Now go for another example, 420. This 420 you can write it as 2 into 210. Again you can split 210 as 2 into 55 and you can split this 55 as 5 into 11. Therefore, finally 420 is equal to 2 into 2 into 5 into 11. 2 into 2 is 2 square into 5 into 11. Therefore, 420 can be written as the product of prime factors as 2 square into 5 into 11. This is again an unique way. This is what is fundamental theorem of arithmetic. Note, writing any composite number in this form is called exponential form or prime factorization method. You see, you wrote 30 as 2 into 3 into 5 and you wrote 36 as 2 square into 3 square. You wrote 60 as 2 square into 3 into 5. We wrote 420 as 2 square into 5 into 11. All these numbers can be written as the product of prime numbers. This type of writing all these numbers is called exponential form and the method is called prime factorization method. The next concept is HCF and LCM. HCF stands for highest common factor and LCM stands for least common multiple. You come across what is HCF and what is LCM in your previous classes. Now here is a question. Find HCF and LCM of the numbers 60 and 75 using prime factorization. I shall repeat. Find HCF and LCM of 60 and 75 using prime factorization. Here is the solution. First of all, write 60 as the product of prime factors. 60 is nothing but 2 into 30. Again 2 into 30 is 15. Again 15 is 3 into 5. Therefore, 60 is 2 square into 3 into 5. And the second number is 75. 75 can be written as 3 into 25. This 25 can be written as 5 into 5. Therefore, finally 75 is equal to 3 into 5 square. Now we wrote the factors of 60 as 2 square into 3 into 5 and we wrote the factors of 75 as 3 into 5 square. Now we have to find the HCF. HCF means it is the product of common factors with their respective least exponents. Here HCF is nothing but the product of common factors with their respective least exponents. You look at these two products. Here what are the common factors you pick up? Here the factor is 2 but there is no 2 in 75. Here is a factor 3 in 60. 3 is also a factor of 75. Therefore HCF is equal to 3 in 2. Here 5 is a factor of 60 and 5 square is a factor of 75. Therefore which is common? 5 and 5 square, the common is 5. Otherwise, now out of these common factors, here the exponent is 1. Here the exponent of 5 is 2. Therefore what is the least exponent? 1. Therefore you have to consider 5 only. HCF is 3 into 5. These are common factors in both 60 and 75. What is the product of 3 into 5? 3 into 5 is 15. Therefore, HCF of 60 and 75 is equal to 15. HCF is nothing but the product of common factors with their respective least exponents. Now let us find LCM. In finding LCM, we have to consider the product of different factors with their respective highest exponents. In the previous case, we took common factors and we took the least exponents. And in finding LCM, we have to take all different factors with their highest exponents. You see, here 2 is a factor, but here there is no 2. Even though there is no 2 in 75, you have to take this 2 square to find LCM. The highest power of 2 here is 2, and here the highest exponent of 2 is 0. Therefore, you have to consider 2 square. Here we have 3. Here also 3. Therefore, take 3. Here we have 5, but here 5 square. What is the highest power? 5 square. Therefore, take 5 square. And you find the product of all these. 2 square is 4, and this is 3. 5 square is 25. 4 into 3 into 25. 425 is 100 into 3 is 300. Therefore, the product of different factors with their respect to highest exponents is LCM, and the product of common factors with their respect to least exponents is HCF. Thank you one and all.